Hello everyone. So today the problem which we will be solving is the third problem of this contest. So before I start, just a brief thing to let you all know that I have started a series called 45 days placement series, and if you want you can learn more about it in the shorts that I've uploaded recently, and please support it if you like it. And now let's move on to the problem. So the problem is you are given a positive integer n. For every integer x from 1 to n, we can write down the integer obtained by removing all zeros from the decimal representation of x, right? So you need to return an integer denoting the number of distinct integers written down. So if you look at n equal to 10, the numbers which are possible are 1, 2, 3, 4, 5, 6, 9 and 1. And if you look at closely at it, only 9 numbers are distinct, so you need to return a 9 over here. Similarly for n equal to 3, they are 1, 2, 3, and these are the things, the example given to you, right? So before I solve the problem or make you intuition about it, let me be clear with something. If you see the constraints of n is still 10 to the power 15, right? Something strange you would look at this, and one thing I can guarantee you is, if the constraints are this big, only two things are possible. Either the problem could be solved using just some ternary or some mathematical operations, right? Either it will be maths or it will be digit dp, right? And this problem I have solved using digit dp, right? So more about it in the next part. So first thing, let's first discuss is, if n is this large, you can directly think of these two things only, right? So if you don't have any idea about what digit dp is, I hope this will make you sense when you will watch the whole video, right? So if you look at if you know about digit dp a bit, there are three constraints or two guaranteed constraints on it, right? First of all, when n is still 10 to the power 15, it is impossible for you to traverse in the whole or traverse the whole numbers, because it will give you a TLE, right? So this uh, guarantees that we need to try something optimized thing, right? And here digit dp comes in play. So whenever we are using a digit dp, right, so there are two things. First, the number should be converted to a string, right? The number is converted to a string, and string s becomes to string of the number, right? uh, Pardon me for my handwriting. To string n, right? After that, if you look, the string has only 15 characters, right? So now it becomes easy for you to traverse on the whole string and complete your answer, right? And the second thing which is there is known as tight, right? If you don't know about digitdp, I will try my best to make you understand how the things are working under the hood, right? But if you want a complete detailed video on that digitdp thing, then I will be more than happy to give the solution to you. But in this problem, I won't be covering all the aspects. The aspects which are needed in this problem, that will be covered by me. So if you look, what the index thing is. So index thing allows us to look at what are the values, what are the which index we are currently at. Let's say I had a number called 850, right? So I need to find all the numbers which are less than equal to n, right? So uh, what will be the size of our string? Size of our string will be 3, right? Let's call it length, right? len. So length will be 3, right? Now if you look at the index part, this part will have multiple options, right? Either value can start from 0, 1 to 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But before you say anything, is 9 possible over at this point, right? No, because our value is 850, right? So let's say if you put a 9 over here, then it will exceed the value, right? It will become greater than n, and that's not what we want, right? So what can we do is, here we will find an upper value, right? So what does this upper value do? This upper value will see what is the value at this point, right? So value at this point is, let's say, 8, right? So we can take all the values up to 8, right? But there is one more constraint to it, right? I will explain it, don't worry. So if you look, upper value will be 8, right? You can't have a value greater than 8 at this point. Okay, makes sense, right? So you can add all the values till 8, not 9. Okay, the next digit or the next character is 5, right? So you can add all values at this index up till 5, right? So you can add 0, 1, 2, 3, 4, 5, 6, 7, 5, sorry, 5, right? And at this point your upper will be 5, but you will be confused to you will be saying, but what happens if we added a 6 at the first place, because we had 8 options, right? From we can't add a 0 at the first place. I hope you have understood why we won't be adding a 0 at the first index or any index be correct, because they have clearly mentioned that you cannot add you need to write down all integers obtained by removing all zeros from decimal representation. That means you will be removing all the zeros which were already present in the number n. So you won't start with an 0, right? Okay, so first thing was that. And what I was saying next, let's say you wrote a 6 over here, right? Now tell me one thing, will your upper value at this point will still be 5? I hope no, right? Because now you can add a 9 over here and again add a 9 over here, right? So how will we calculate this, right? So let's say you added a 6 over here, right? And if you add a 6 over here, your upper value at this point was 8, right? And you added a 6, right? You added a 6. That means now you are free to add any integer from this point till the last index. You can add anything whatever you want, right? So here comes type, right? So let's say your character was less than what you added, right? So your upper value was 8 and now you added a 6, right? Now your type becomes 0. What does this type equal to 0 signify? This type equal to 0 signifies that now you cannot add values. Now you can add values which can be anything, right? Means let's say your upper value was 8, you added a 6 over at this point, now your type became 0. Now from now onwards this type won't change for the further strings, right? Means let's say you added a 6, right? For now rest on the values type will be 0 for this. Great. Now if your type is 0, then you can add any value from 1 to 9. I hope this thing is clear to you. What is the value of type, right? And if let's say you added a 8 over here, right? Now at the next point, what will be the value of type? Value of type will be 1, right? I hope I'm making sense to you. So if the value of type is 1, now what are the constraints for you? The constraints are still, let's say number was 850, right? If I'm not wrong. So now at this index you can add any value from 1 up till 5, right? And again follow the same process, right? So if once type becomes 0, then for the rest of the string it will be 0. And if the type is 1, you need to every time check the value is if the type value is 1, then you need to check that have you crossed your limit or not, right? So upper value, have you crossed it, or are you at the verge of crossing the upper value, right? I hope I'm able to make things clear to you. And one more thing, I have used it in my code is dp of this value is 20, because I have used, you can use 15, right? And I have used 20 because I just wanted to be on the safe side. That's why I've used 15 on this, 20 on this. See, 2 is the type value, and again you will see one more dp2. Now you might be confused why I have explained only two states to you, that was dp of index and type. What's the third state? So when you are calculating all the digits, right? Let's say you are calculating till 850, right? So at this point we will start from 0. We can add one constraint, that we can start d equal to 1, right? That might be a little bit helpful for us. But what I did was I have started from 0. So I can explain to you why I have used d equal to why I have used started at this point, right? So the thing is, whenever d equal to 0, right? So things is like this. You can, every time you can, digit dp will have a value 0 at this point, right? It can have 0 0 0 0 1, 0 0 0 0 2, right? So it is, isn't it equivalent to 1? Isn't it equivalent to 2, right? So I am just having a flag function, right? Flag function that will store that have I started it or I have not started it, right? So this was it. So this things denote that have we started at this point or haven't we started, right? Great. So let's, the code is very neat and clean. I will provide the code to you in the comments, and let's look at the code now. I hope things were clear to you, why the states are what, and I have explained how can you take the values of the digit D, right? Okay, so let's look at the code first. If you have any doubts, please do let me know in the comments. I will be more than thankful to you that I could help you. So let's look at the code first. So this was our function, right? In this, if n is less than 0, then return 0, vague edge case, right? And in this, I'm calling a solve function, right, and creating a dp. So let's look at the solve function. How does it go, right? So the solve function is if you reach the last index, right? So what are we doing is, if index is equal to length, right? If index is length and if we have started, then we can return a 1, right? So let's say you have started, you have, let's say, if you have used many zeros and after that you started with a value 3 and then a 5, a random example, right? So if you have started, then this is a valid answer, right? Because we will add our constraints like this, that we can somehow be in the range, we won't exceed n, right? So that's what I'm doing. If you have reached n and you have started, then we can return a 1, right? That this is valid 1, right? And if you have not started at all, right, that means you are still at 0, right? So return a 0, right? So I hope this part was clear, right? And one basic, I think, if you know a bit dp, then you definitely know that this thing is used every time, right? So this is called memoization, right? dp of index, tight, and started, right? If this is not equal to, wait a second, started is not equal to -1, means you have stored the value somewhere, then you can simply return it, right? Great. And int upper, right? So if tight equal to 1, means you are bounded by values, right? Let's say your number was, again I'm using 850 because that's what the example I've used. So let's say 850, right? And tight, initially tight will be 1, right? Because you are bounded by some values, right? So if tight is equal to 1 and your digit or your character is 8, then you can only pick values from 1 to 8, right? So that's what I'm doing. If your tight is equal to 1, upper will be simply s minus s of index minus 0 to get the integer, right? Else upper will be 9. So if tight is equal to 0, that means you have all the values that you can take up till 9. I hope this thing I've explained earlier to you as well, and this thing might be clear to you, right? So long answer equal to 0, and now we will traverse from all values of 0 till upper, right? And I am calculating next started and next tight, right? So what does the next started thing do? So if started is equal to 0 and if d is also equal to 0, means you have not started till now, and the value of your character or the digit that you are going to place over at this point is 0, the next started will be 0, right? And if started is equal to 0, means you have not started, right? But the value over here is, let's say, 8, right? Then you can point your next started to 1, right? Okay. And if your started is already, you have started, means your started value is already equal to 1, and if your d is equal to 0, then there is no point of calculating it, right? If your value is 0, right, then you won't calculate it, right? And else next started will be 1, right? Great. Now if tight is equal to 1, what does this mean? If tight is equal to 1, if d is equal to upper, right, means tight was 1, right? What does tight mean? That you are bounded by some value, right? And your d is also equal to upper. Let's say upper was 8, right? So if upper was 8, tight was 1, what can we do? We will simply do next tight equal to 1, means at the next function, whatever value you are having, the type value at that point will be 1, right? Else your next type will be 0, right? What does this mean? Let me explain it. Let's say your type value wait a second, let's say your type value was 1, right? Type is 1 and your d is not equal to upper, means d is equal to, let's say, 4, right? So at this point, whatever next function you will call, that will have a type value of 0, right? Because now you are not bounded, you have used a 4, and now whatever integer will come, you can add a 9 over here and it will still be less than equal to 850, right? I hope this thing makes sense to you. And next type will be 0, right? And if type is already equal to 0, means let's say you have used a 4 over here, then furthermore at every point you have all the freedom to use any digit or any character you want, right? So next type will be 0 and answer will be equal to just calling the solve function, and it will calculate the answer for you, right? So answer will be digit dp of index type started equal to answer, right? And you can return the answer as well, right? So I hope the problem statement and my code was clear. I will add the code in the comments for you as well, so that you can understand this easily, right? So I hope you have learned from this video. If you have any doubt from this, you can definitely do ask in the comments. I will be more than happy to again help you out, right? And please do also check out the new series which I'm going to start. Thank you for watching.